Thank you. Thank you everybody for joining us today, wherever you're joining us from the world. As has been said, we're going to be talking about migrating your network data into the new ArcGIS Utility Network. This is the third in a series of webinars. We've previously discussed UN readiness, getting your data prepared before you move into the utility network, and also the importance of validation. And today we'll be focusing on some of the best tools to use, the approach to take towards the migration, and also we'll be sharing some top tips and tricks that we've learned over the way through our own experience. So first, a little bit about One Spatial, who we are and what we do. So we enable a more sustainable, safer and smarter world by helping organizations unlock the value of their location data. We focus a lot on location master data management. We have our own data solutions and software, and this is why utility navigation is a particular good fit for us. So global presence, as you can see from the map on the left-hand side, we are headquartered from Cambridge, but we have offices all over the world and work in all of these different territories. You can see there from the right-hand side, we work with a really broad range of customers, largely across kind of government, utilities, obviously, and transport. And in order to deliver our solutions, we often work with a variety of partners as well. So first of all, let's just touch on what the ArcGIS Utility Network is, why you might consider migrating to it, and also what the benefits might be. So really, it's a next generation system for managing your utility network data. So it's all about modernizing your kind of data assets. It's been released by Esri. It's industry focused, which means it's configurable whether you're working with electric, gas, water, etc. And it really brings together an integrated network. So kind of in one system, you manage your structural and your domain assets. It is highly configurable, and we'll move on to that in a bit more detail, but you can design the right model to meet your very specific requirements. And we know they requirements and needs do differ between different utility organizations. So it's designed to suit that flexibility. And kind of ultimately, it's all about creating a digital twin of your real world assets in a kind of digital space. So a very accurate virtual representation. Now, the reason it's becoming, I guess, increasingly important for those who are existing Esri users, you may already be using the geometric network. Well, that geometric network is being retired alongside ArcMap and some of the other tools within the kind of Esri suite in what's just a couple of years now, so spring 2026. So that is a date to keep in mind, as I say, if you are an existing user of the geometric network. Now, of course, utility network is not just for those who are kind of existing Esri customers. It may be that you want to migrate your data from a different system into the Esri solution. And just to note on that point, that the One Spatial utility network migration solutions are kind of agnostic to that point. So whether you're currently using Esri or not, our tools can help you along the way. So what are the benefits of migrating? Okay, so we're migrating our data into this nice new modern digital twin, but why might we want to do this? What benefits are we going to be able to get from this new system? Well, it is very and can scale as your needs change across your organization. That might be, for an example, that you're having more kind of end users, more people interacting with your geospatial data, and this system's going to be able to help you do that right across the web, across desktop, across mobile as well. Those people that are out in the field, maybe collecting data or reviewing data. It puts a real focus on data quality. So that data quality and the integrity of your network is going to be controlled. So there are rules within the utility network system that ensure that data quality. And ultimately, that's going to help your organization make better informed decisions. And you're going to have more confidence in the decisions that you make if you know that you have high quality data underpinning those decisions. It really enables the kind of future proofing of your utility. It's designed, as I say, in very modern systems based architecture. And what this enables kind of ultimately for your users is kind of advanced visualization, really great kind of analytical tools that come out of the box, if you like. So you might find that there's less need for kind of bespoke code and applications. You can do a lot of the stuff that you might have been doing previously elsewhere. You can do it all within the utility network system. And advanced editing as well is a really big benefit. So we spoke about the rules that kind of ensure the ongoing data integrity and data quality. Well, you can also have really advanced kind of editing rules as well, so that can make your editing more efficient, but also ensures that when edits are being introduced to your database, that they are correct at the point of the edit itself. So just looking at what moving your data into this new system might entail, we're going to move on to much more detail around some of these points. So you will find that in many ways it's like any other data migration, but it does differ. It is quite a unique system, and you will soon find that there are differentiators. So as we've already discussed, it does have a big reliance on data quality. So that is a really important point that I will be stressing throughout the rest of this webinar. It's important that you assess and you clean your data, and ideally you do that before you move. The model itself, which we will be taking a look at in more detail, is very flexible and very extensible. So what that means from the very start of your kind of journey of your project is that you might not know the target model. So that's something that needs to be designed to make sure that it meets your organization's needs. So really, all told, this is not it's not a process to be taken lightly. As we've seen working with clients, as I say, right across the globe. It will be a journey. So what I'm going to talk to you about over the next half an hour or so are some of the things to consider for your approach, some of the tools that can help, and also, as I say, some kind of top tips and tricks as well. So when we say this is going to be a journey, that's because there is ultimately a bigger picture at play here. And this is a wider opportunity for your organization to kind of upgrade and modernize your kind of GIS holdings, if you like. So more than just a data migration, this is an opportunity to do a kind of, as I say, a modernization, a real digital transformation. So it may be the case in your organization that you've started to migrate your kind of architecture to the cloud. That's a very common thing that we're seeing, very common trend. So this may be part of that journey, or actually this may be the trigger to start that migration to the cloud. Now, of course, when you're moving to the cloud, that in itself is quite a big deal, and there's lots of things to consider. it's very likely at this point of migrating to the utility network that you'll be also upgrading your kind of Esri stack, your Esri enterprise, possibly the kind of underlying databases. So it might be a case of upgrading, more than one piece of software here. And again, that move from ArcMap to ArcGIS Pro for your desktop users. And also, it's a real good opportunity to move more of your maps and your geospatial applications to the web. So, an opportunity, as I say, to move those applications from the desktop to the web, possibly into the cloud whilst doing so. So things you will want to consider are the impacts on not only the data and the software and the architecture, but also the impacts that this change will have on your people and your existing processes. So in terms of people, might need some training, might want to consider who has access to your GIS data via different apps and maps, and whether they can be moved or migrated to different places. And really, reflecting on this, opportunities to do such a digital transformation don't come along very often to most organizations, and possibly even more so with utility organizations. So it's a chance to reflect on your data holdings, on your architecture, on your infrastructure, and really consider, are there other improvements that we can make at this same time as well? That may be that, in your existing GIS system, you may have some known issues with your data. We see that quite a lot. That's very common, that people know that. One example might be that there's a unique identifier, a field that should hold unique identifiers in your data set. Sometimes it's well known that they're not actually unique. You may have fields in your data that are inconsistently populated, and like I say, this is an opportunity to kind of look across at all those kind of existing business rules and see what further improvements you can make. It's very important, before you start out, and as you're early in the kind of program or project, that you understand your current state. So understanding your as is going to help you kind of spot any gaps or any existing issues and capture the real needs of your organization and your actual requirements. Again, the likelihood is you will have lots of stakeholders for your data, lots of different user types across your organization, whether they're kind of people that just view the data, people that make decisions based on that data, running analytics, or people that are editing, capturing new data. You may have external contractors also that are stakeholders into this data set. So it's really important to get a really good view of your current state. And this is going to enable you to understand your existing model, which ultimately helps kind of inform the best way to design the new model. It's going to help you articulate what you want from the migration and build your internal business case. And it's an opportunity, as I say, to reflect on who's using the data, who's using your GIS software, who's using your various maps and apps, and kind of take a look at what those user types are, what their needs are, can we improve their kind of user experience, but also take a look at your licenses as well across the organization. And also another important factor, it's highly likely again that your GIS is connected and integrates with other systems within your organization, such as customer data, etc. So it's really important that you have a good understanding of what those key integration points are, so that when we map that data across to the new model, we can maintain and, if possible, kind of streamline and improve those integration points as well. So if we take a bit more of a detailed look at the utility network model itself, it is a very structured model, yet it is also kind of highly configurable, and you can customize it to suit your existing data, but also, you know, as I say, your organization's needs, the needs of your users. And actually, it's an opportunity to look ahead and think about what needs you might have in the future as you know, new innovations and different things come along. So on the left-hand side, we can see the kind of overall structure of the utility network. And you'll see there we've got the two columns for the structure network and the domain network. That domain would be your, you know, water, gas, sewer, etc. You can see that there is a very set structure to the feature classes. So in the domain network, you'll see that we have device line, junction, assembly, and subnetwork lines. Those things will generally always exist. And then just coming up a level, you'll see as well that the rules that dictate the network sit across the entire network, and that includes both the structure and the domains. Now, if we move over to the right-hand side, this is a view of a utility network data set opened within Esri, within ArcGIS Pro. And you can see from the left-hand panel of the window there, the kind of list of feature classes. And we can see that water device is expanded. And what this shows is then the next level down of categorization, which is the asset group. And then the small image to the right-hand side, which is inset there, shows what that looks like if we expand the asset group. We then list out asset types. So you can see that there's a hierarchy to the network from the very top level, the utility network. That then contains these two networks, one for structure, one for the domain. Within those, you have a set of feature classes, and within each feature class, we then start to categorize our data into what are called asset groups, and then further categorization into asset types. Now, some of this terminology might be new to you, and if it is, then you know, I totally appreciate. When I started working with utility network about 2 years ago, I didn't know the difference between asset group and asset type and asset package, but you very quickly come to pick up the terminology and kind of understand how that all maps to each other. But hopefully that just gives you a good understanding of what the model looks like. It may be the case if you're in currently using the geometric network, that you have many feature classes. Again, we see that that's not uncommon. They're often very different. There'll be kind of some bespoke custom kind of feature classes within there, normally prefixed with a letter to determine which domain they belong to, and hopefully you can kind of get an idea of how they may map into these new feature classes, and then you start to break them down and categorize them using the asset groups and asset types. So that moves us on to thinking about how we actually, you know, go ahead and transform our schema from its existing model into our new utility network model. So moving it from A to B. Well, there is some help out there, thankfully, for this. So Esri do release a set of what are called foundation models. These are available to download from the Esri solutions. And there are various industry configurations. So you'll find an electric model, a gas model, a water model, etc. And these really do give us a great starting point. So we're not staring at a blank page. We've got a starting point, which is, you know, if you like, a template model. There are also many tools available to do kind of schema transformation. So some of those, you know, there are data management tools within the Esri suite itself. F&E is a good tool. That's the image on the bottom right hand side. That's a snippet from a work migrating data into the utility network. One Spatial have our own rules engine, which has a schema transformation capability. And there are lots and lots of tools in the market to enable, you know, moving data from kind of schema A to schema B. And that may be determined by the familiarity of your organization and what you're maybe what you already license or what you're most comfortable kind of using. And the likelihood is, depending on the tool, of course, but the likelihood is that this will be a data-driven transformation. And what that means is the mappings are very commonly stored in a spreadsheet. This means that actually those mappings are very human readable, really easy to share. It's a nice way to collaborate across teams as you run workshops, for example, to design that model as a group, and also very easy to kind of version control and keep track of your mappings between each iteration. I already mentioned an asset package, but just to describe what that is, it's actually just a file geodatabase that has some kind of specific tables and configurations, and it acts as a staging database for your utility network. And what that enables you to do is, rather than pushing data from your source system all the way through end to end into the utility network, it means actually we can move through iterations of migration much more quickly and much more efficiently. So kind of working in an agile manner, if you like. The reason that's helpful, and this is also following Esri's recommendation, is because this is going to be an iterative process. It's highly likely to impossible that we're going to get the model right on our very first go. So we're going to want to work through iterations, and therefore it's important that we can move through those iterations quickly and efficiently. We've already touched on the data quality aspects and the rules, and I'm just going to go into those components in a bit more detail. ArcGIS Utility Network is built on a foundation of rules. Just going back to the diagram I showed about the model a couple of slides ago, we had rules right at the top level. They are stored, at that top level of the network, and they are an extremely important component of the utility network to ensure that integrity and quality maintains within your data. So we have a variety of different rules, network rules, attribute rules, and as you can see here, they're kind of various categories of these rules. So some that determine the connectivity within your network, so which features can connect to other features, and if two features are found in the data set where there is not a corresponding rule, then that will ultimately throw an error, and that will be presented to the user to say, hey, there's no rule for this kind of connectivity. You need to make a change here in the data so it conforms to the rules. Same for containment and also structural attachment. And you can see from the diagram that the three examples across the bottom. So things like association rules, these are non-spatial connections between two features that don't actually intersect geometrically. But then there are also rules that determine which relationships can exist between points and lines. So moving on to why this is so important. And actually, if you'd asked me 6 months ago, is data quality important to the utility network, I would have said yes, absolutely. If you ask me now, with the experience I've gained working with various clients, I would say actually it's not only important, it's critical. It's absolutely critical to the success of your migration. And if we take a look at the best practice quote from Esri, for a properly functioning utility network, the error count should be 0, if not as close to 0 as possible. And if you do have 10,000 errors in your data set, then this is going to severely impact not only the performance of the system, but also the functionality that is available to your users. So it's critical. It's really, really important. Now, 10,000 is a kind of magic number, if you like, and if you breach that, then performance will be severely degraded, but it will also be degraded right up to that point. So it's absolutely, it would be our recommendation from setting out on this journey, on this move, to get your errors down as close to zero, if not zero, if that's possible. So when we think about, okay, that being said, we need to fix our existing data. Well, you've got various opportunities to fix that data from, if you like, now to your migration and beyond. Now, fixing your data now in its current system is probably the easiest thing you can do. It's easiest because of familiarity with that system. It means that you're not going to, these errors aren't going to be presented to you during or post migration. And it's just generally the easiest place to start. You would have the option to do some data cleansing, data fixes during the migration, what I like to call in-flight data cleanup. That is possible, but again, will come with some risk, and you won't know until after that migration whether those fixes have been successful, and those fixes won't be in your source data. And the likelihood is the next time you do that iteration, you'll need to repeat the same fixes, or indeed store them in some kind of intermediary database. These things are far from ideal and just make the management of the migration iterations much more challenging. And finally, you can of course accept some level of error in the data set and have a plan to fix those up post migration. That again does become more difficult because the likelihood of having time to set aside and make those fixes is less likely once the new system's in place and you're back to kind of BAU operations. As I say, this project is an opportunity to make sure we get these things right whilst we can. So our recommendation would be fix your data as early as possible, preferably before migrating. So moving on to the kind of One Spatial utility network solutions. These are our kind of accelerator applications. So on the left-hand side, we have the Readiness app. This is a SaaS-based application, and it's all about what I've just been talking about, really. Assessing your existing data in its current model, current schema, but making sure that your data is fit and ready for migration. Of course, then in the middle, the utility network migration service. This will be that data-driven schema transformation that we discussed. This will include the design of your target model, making sure that you are moving to the right utility network model. And within this, you can utilize the One Spatial kind of skills and expertise in both the utility network, but also in kind of data management, quality, modeling, transformation, etc. And on the right-hand side, we also have a validation app similar to Readiness. This is a SaaS-based application where you submit your data, run it through a set of rules, and are presented with a report which tells you if that data that you have migrated is correct and accurate, and it's all present, and it all fits the rules that you've configured within that utility network. Right through this situation, this process, we will utilize the asset package as previously described. And all of this, is because it is much easier to capture and fix any data quality issues before you move and publish into the utility network system. So this is what those kind of tools, this is kind of how they're used within the flow, if you like. And so they really do enable that efficient and kind of agile, iterative delivery. So UN Readiness is all about assessing your source data, and then we migrate into an asset package, and then we validate the data and the information that's held within that asset package. And we do all of this before publication, go live, and any additional kind of configuration that needs to happen within the system. All underpinned by One Spatial's One Integrate rules engine. So from an end-to-end process, obviously everybody's mileage may vary. Situation looks slightly different between each utility company, but this might be what the kind of flow of your data looks like as you work through the project. So at the very start, we want to review our as-is and assess our current state, and also we want to start fixing our data as soon as possible within that time frame. Then as we move through, we want to look at our integration points, we want to design the right model, and then we'll start to push our source data into that new model, which we will configure an asset package to reflect that model that we design. Once data is in an asset package, it does mean that in parallel you can be doing other kind of development work, such as applications or looking to replace bespoke code. But we will keep iterating through, so readiness, migration, validate, make sure it's present and correct. If not, we might want to go back, do more fixes at the readiness stage, another migration, validate, until we, the idea being that with every iteration we learn more, but we also increase our confidence, so that when we come to go live, when we come to publication, everybody is confident that the data's right, the model's right, and that this is going to meet the needs of our organization. So reflecting on One Spatial's experience to date, I thought I'd just pull out some kind of top tips, things to look out for, things to consider as you're setting out on this journey. So personally, I think a really important one is avoiding any black box type processes. So that would be a process where you feed your data into your system or send it off to a third party, and then you receive your data back in a utility network of some degree. What's really important is that you maintain kind of transparency, and that there's accountability and observability across all of the data processes, and that the people that own and manage your data are really, as I say, have that transparency on what exactly has happened to your data. That's just a trap that you won't want to fall into. I'd suggest that as early as possible, people who are going to be involved in this kind of migration project start to get familiar with the utility network model and all of this new terminology that comes with it. I would consider doing a proof of concept as early as possible, and maybe keeping that as small but beneficial as possible. I've already mentioned about your opportunities to fix up your data, and I would avoid making in-flight changes, as we've seen how that can kind of trip you up, and just make the management of the data through the processes just a lot more tricky than it needs to be. If you manage multiple domains, so we often see it might be clean water, wastewater, electric. We've worked with organisations that only manage one domain. We've worked with organisations that manage 5. So we know there's a real mix. And I'd say it's important to actually manage each of those separately through this process. It may be that you have different stakeholders for each. Certainly, each one will have its own data model. There'll be nuance and uniqueness to each, and it's just much easier if we keep and manage a degree of separation through this flow. And actually, because the utility network is so configurable, it can go from basic to what you might term medium to actually very complex models. And I would actually recommend starting by just getting the basics right first. So maybe that first iteration that you do, We don't worry too much about some of the additional functionality, etc. We just make sure that we can move our data into a model and get the topology right. That's the really important aspect. Once you've done that, you can then start to layer on additional levels of complexity to suit your needs. I mean, I can't stress enough this next point, but I would say, you know, clean and cleanse your data as soon as is possible. It might be that you just start that in kind of dribs and drabs, if you like, appreciating that resourcing these kind of tasks can be a challenge. But yeah, as I say, data quality is critical to the success of the migration. So the earlier you can get a handle on that, the better. And going right back to one of my first slides, I guess sort of make the most of this opportunity. You know, zoom out, if you like, and look at the bigger picture that we mentioned. What other things can we fix or improve, make more efficient, whilst we've got the opportunity to go on this digital transformation. We have some further viewing on our website. So the bottom two links there, if you go to youtube.com/One Spatial group, you will find the previous two webinars from this series. So we covered Don't Let Dirty Data Impact Your Network Connectivity, was all about UN readiness and how it's good to clean your data as soon as possible. And then a second webinar about boosting the confidence in your data through validation. And if you go to onespatial.com/UNM, you can find all the information you need about the utility network itself, about the One Spatial solutions. And we've got some nice customer success stories on there, including one from Hunter Water, a company in Australia who we work with, and a nice quote on the right-hand side there. And there's a kind of video you can watch on that webpage. But when we worked with Hunter through this project, we kind of took them from what was previously a reactive approach to a proactive approach to the assessment and cleansing of their data, which ultimately has helped them move their data into the utility network. So that's it from me. So I'll just hand over and see if we have any questions.